Linear regression model. How can we apply linear regression model on input data set, and how do we get the algorithm to find the predicted values? First of all, in the input data set, we need to identify the independent variables and the dependent variable. Dependent variable is also known as output or target variable. Let's analyze the data first. In the given data set, we have two columns, height and weight. Let's take height column as input column. Input columns are also known as features, and weight as the output column. So output is something that we are going to predict. Now we may wonder that we already have the data set, then what are the values that we want to predict? So this data set that we can see as input data set is a training data set, and we train the linear regression model using this input data. Linear regression model will derive a formula to predict the output variable. So whenever to a trained linear regression model we provide input data, it is going to predict the output for us. So this is the simple logic. Let's look into the code. First of all, here we are using different libraries like pandas, sklearn, matplotlib and scipy. So pandas we are using to load the input data, do any kind of data transformation in the feature columns. Further, sklearn we are using because sklearn is the library that contains the machine learning models. So linear regression model is something that we are going to use. It also contains the difference matrices that are used to measure the model. Next, matplotlib we are using to plot the output and input data, and we can analyze the data set using the plot or visualization that we may draw. Then scipy we are using to check the correlation between input and output variable. At this point, we are loading the data by reading the input file height and weight data, and once we load the data comes in a data frame. Further, we can analyze the data and see the row count and column count in the data set. We need to note that the sklearn model that we are going to apply in this program requires data in the form of NumPy array. So here at this step, we are converting the two dimensions height and weight into NumPy array. Once this conversion happened, we would initialize the linear regression model and fit the input output columns in the linear regression model. Once this initialization is complete, we get a trained model. In the trained model, we can see what are the intercept and coefficients. Then we can apply or we can use the trained model to predict the output of the unknown values. Before we move further, let's understand what are intercept and coefficients. So here if you see, there is a dummy formula that is mentioned: y predicted equals b0 plus b1x1 plus b2x2. So once we train the linear regression model using the input data, what we actually derive are the coefficients for the input features. And based on those coefficients and the input features, we derive a formula for y predictions. Now b1 and b2 in the given dummy formula are the coefficients and b0 is the intercept. And as it is a linear regression model, so there is a linear dependency between independent and dependent variables. or there is a linear relation between the input features and the output variable. So there is no power or exponent value of the features that are present in the algorithm. Next, we can see how we can find the value of intercept and coefficient from the model. So at this step, once the linear regression model is initialized and trained with the input data, we get the model, and from the model we can derive the intercept and the coefficient values, and coefficients are the weights that we apply to the input variable. For example, here it is the input variable x1 or height. So once we have the formula with us in the form of the trained model, we can predict the output variable y for an unseen x data. Now there could be a possibility of error in the y predicted values. And how can we find what is the value of that error? We can find it by seeing the difference between the values of the actual y and the y predicted value. So we can use mean absolute error function to find the mean absolute error in the actual value of y and the predicted value of y. So this is how we can find the mean absolute error. Next, we can use the model to predict the value for our input data set itself. So this is how we are predicting what is the y predicted value at the index number 80 of the input data set. Further, to analyze the data, when I say data, the input data and the y predicted values, we can use scatter plot. So in the scatter plot, the dots that you would see, they show the actual coordinates of the input variable and the output variable. Next, we draw a plot, and the plot that represents the green line is the best fit line for the input x value and the y predicted value. So if you see this best fit line, it is the green line that you see running over the scatter plot. Next, as we discussed that there is a margin of error in the y predicted value, we shall see how the spread looks like in the y predicted value if we add the mean absolute error or if we subtract the mean absolute error from the y predicted values. And that is what we can see using these blue lines. So these two blue lines are very close to the y predicted green line. So the spread is uniform. So this is how we can analyze the model and how we can further use the model to predict the unknown value of y for the unseen data of x. Now in case we want to see what is the value of correlation, we can use Pearson correlation coefficient function and check the correlation between the input and output data. So in case you find the video useful, then comment, like, share and subscribe.